Now it is the 10th problem. A grindstone of radius 0.5 meters starts from rest and has a constant angular acceleration of 3 radians per second square and find the resultant acceleration of the particle on the rim at the end of the 2 seconds like this. Suppose if at all this is the grindstone we are taking, and here now there are the two types of accelerations are there. So for the particle which are on the rim, for the particle which is on the rim, a grindstone of radius that you are given, it is a 0.5 meters, r is equal to 0.5 meters. And the next one is from rest and has a constant angular acceleration of 3 radians per second square. Alpha is equal to 3 radians per second square is here, that is alpha, and thereafter find the resultant acceleration of the particle on the rim at the end of the 2 seconds. T is equal to 2 seconds is here. And first of all, there are the two types of accelerations are acting on that particle. So here also you are supposed to find out what is the resultant acceleration of the particle. There are the two accelerations. Two accelerations means one is the tangential acceleration and it is taken as the AT, and another one is the centripetal acceleration or the normal acceleration or the radial acceleration. So centripetal or the normal or the radial acceleration which is acting towards the center, and it is a tangential. So that's why tangential acceleration, because here that a particle is executing that non-uniform circular motion, it is not the uniform circular motion. If at all it is a uniform circular motion, then it possesses only that one type of acceleration, that will be the centripetal only. Now here it is a non-uniform circular motion, that's why both will come. Then you have to find the resultant of these two. You have to find out the resultant of these two. In finding that tangential acceleration, it is very simple, it is the r alpha. R alpha means R already given to you, it is the 0.5 meters, and thereafter it is the alpha is also given there, it is the 3, and it will be the 1.5 meters per second square. So that is simple. The problem is with this centripetal only, and for that centripetal it is taken as the AC is equal to R omega square. So R omega square is here, and it is the, that is the centripetal acceleration is the R omega square, and you have to find out that omega. And how to find out that omega means after the 2 seconds. So that's why after 2 seconds, it is the omega is equal to omega naught plus alpha t. Omega is equal to omega naught plus alpha t. Omega naught is the 0, and again that alpha is the 3 is here, and t is equal to how much after the 2 seconds. So that's why it is a 6 radians per second. 6 radians per second, and r omega square is equal to, r is already given 0.5, and again the 0.5, omega square is equal to 6 square is here. So it will be 18 meters per second square. So now we got these two values. One is the centripetal and another one is the tangential. Now you have to find out the resultant of these two. The resultant of these two, A is equal to square root of AC square plus AT square is here, and that can be taken as the square root of, it is 18 square plus 1.5 square is here, and as you already given that will be closer to this value 18.07. So that answer is given that 18.07 meters per second square. So this will be the answer. So here only the problem is, here the particle possesses two types of accelerations because it is not the uniform circular motion, it is a non-uniform circular motion. So that's why tangentially is there and the centripetal is there, and you have to find out the resultant of these two. That's all. So that's why here this problem is also completed, that is the 10th one, and we are coming to the 11th problem. So now it is the 11th problem that you are given, you are given some diagram like this. In this case, so these are the rotational axes are given 1, 2, 3, 4. One is along the diagonal, and the next second is this one, and here it is the fourth. This is taken the third. So a grindstone, that is a movement of inertia of a thin square plate ABCD of uniform thickness about an axis of passing through the center O, and perpendicular to the plate is. So perpendicular to the plate is. So here in this case you are given some options also. Those options are, the first option is the A is I1 plus I2, and the second one is here you are given it is the 2I3. So it is the 2I3 is given, and the third option it is the I1 plus I3. I1 plus I3 is there, and I1 plus I2 plus I3 plus I4. So I1 plus I2 plus I3 plus I4. So that's why you are given, these are the four options. Once again I tell you these options. It is I1 plus I2, 2I3, I1 plus I3, and again those four options are also given. And this problem comes under more than one answer. More than one answer. So you are given the four options like this, I1 plus I2 like this. Now, first of all, this is the first rotational axis, and again this is the second axis, and these are nothing but the diagonals of this rectangular frame. So these are nothing but the diagonals. When these are the diagonals for this rectangular frame, and that's why when you are taking that perpendicular axis, IZ is equal to IX plus IY. That is according to the perpendicular axis. So because of that reason, you are also here in this problem also you are supposed to find out what is the moment of inertia. So the moment of inertia for the thin square plate ABCD of uniform thickness about an axis of passing through the center O and perpendicular to the plate. So perpendicular to the plate and passing through the center O means like this only, and you are supposed to find out the moment of inertia about this axis. In this case, IZ is equal to IX plus IY. IZ is equal to IX plus IY. We apply this perpendicular theorem for the diagonals as well as for this 3 and 4 also. So that's why from figure what we can have, that is the I is equal to I1 plus I2. That is the first equation. That is the first equation. It is the I is equal to I1 plus I2. And similarly, it is the I is equal to I2 plus I3 plus I4. So that's why I3 plus I4 is there. That is also second equation. Why we have applied this perpendicular theorem means because here also this is for the square frame. Square frame and 1 and 2 are mutually perpendicular. That's why we can apply the perpendicular theorem. Then you can get the moment of inertia about this axis. So that's why I is equal to I1 plus I2. This is the perpendicular theorem that we are applying. And here in the second case, I is equal to I3 plus I4. And now when you are taking this 1 and 2 are symmetrical because this is a square frame. It is not the rectangular one. It is a square frame. For the square frame, 1 and 2 are symmetrical. So that's why here from figure what you can understand, that is the I1 is equal to I2. Next, similarly, I3 is equal to I4. I3 is equal to I4 is there, are there. So that's why first of all, I is equal to I1 plus I2 is given. That's why it is correct option. And the next one is I is equal to I3 plus I4. But in place of the I4, we can apply the I3. That's why I is equal to 2I3. That is also correct option. And we have to check that remaining 2. We have to check that remaining 2 means it is the I1 plus I3, and again, definitely this cannot be the correct answer. Definitely this cannot be the correct answer because I1 plus I2 plus I3 plus I4 cannot be the correct answer. So the moment of inertia, that is the of I1 plus I3, that only we have to check whether it is correct or not. So it is I1 plus I3 means, so first of all, here what we are taking, when you are applying that I1 here, that is the from 1, when you are applying that I1 here, then it is the I is equal to 2I1. I is equal to 2I1 when you have taken this one. So next, similarly, I is equal to, in place of the I4, if you are applying this one, so that's why it is the 2I3. When LHS are same, that's why we can equate that RHS. So that's why, therefore, I1 is equal to I3. I1 is equal to I3 will be here. So because of that reason, that is the I1 is equal to I3. So once again I am coming. So that's why, so I is equal to, in place of that I1, in place of that I2 or the I1, it is I is equal to 2I1 is here. 2I1. In place of that I2 we have applied, this is the 2I1 is there. And in place of this one, that is the I4, that is the 2I3 is coming here. Now I1 is equal to I3, and because of that reason, I is equal to I1 plus I3 is coming here. So once again I tell you, now first of all, this is the square frame is given to you, and this is the perpendicular theorem that we are applying. According to that perpendicular theorem, this I1 and I2 both are mutually perpendicular. So we are applying that perpendicular theorem, we have got this one. I is equal to I1 plus I2. And similarly, when you are coming to this one, I is equal to I3 plus I4, because these are also mutually perpendicular. and these are symmetrical. I1 is equal to I2, that's why these are same, and I3 is equal to I4, that is also same. And from 1 what you can take, that is the so I1 is equal to I2, and these are the results. I is equal to I1 plus I2 is there, and if you place, that is the, in place of that I4, if you are substituting that I3, then you are getting that 2I3 also. And if you are taking, that is I is equal to 2I1 or I is equal to 2I2 or I is equal to 2I2. Next, I is equal to 2I1 or I is equal to 2I2. I is equal to 2I3 or I is equal to 2I4. I is equal to 2I4, and from that, from these results, we can prove this one also. So once again I tell you this one, it is the I is equal to 2I1, because in place of the I2 we can apply that I1, that's why 2I1, or I is equal to 2I2. Similarly, I is equal to 2I3 or I is equal to 2I4. So from these results we can prove this one also, that is the moment of inertia about the O is equal to I1 plus I3. So now it is, this is the more than one option, that's why 3 are correct. And you may get confused, that is the perpendicular theorem, that is the 1 and 2 and 3 and 4. You are applying that perpendicular theorem here only. And here you have to understand that is equal to the 2I3 also. And that IO is equal to, that is the I1 plus I3 also. So these are also 2 correct answers, more than one option. Now there is a 11th problem is completed. And thereafter we are coming to this next problem. In this next problem it is mentioned, that is the moment of inertia of the solid flywheel about its axis is 0.1 kg meter square. So first of all we can draw this figure. So in this figure it is given, so this is the pulley is here, and it is the mass is the 2 kg, m is equal to 2 kg is there, and thereafter this the tension is here, and it is the mg, and this is the radius. So the moment of inertia of the solid cylinder, the moment of inertia of the solid flywheel about its axis is the 0.1 kg meter square. So that's why it is the moment of inertia is the 0.1 kg meter square is there, and thereafter it is a tangential force of the 2 kg weight is applied around the circumference. So that's why you are given it is the 2 kg weight. 2 kg weight is that, so it is applied around the circumference of a flywheel with the help of a string and a mass arrangement as shown in figure, if radius of that wheel is the 0.1 meter. So that's why R is given, it is the 0.1 meter, and thereafter it is the find the acceleration of that mass. Find the acceleration of that mass. That is the first question is there. And the second one is, if instead of that hanging weight, the string is pulled by a constant tangential force of 2 kg weight, then what is the acceleration of the mass? You have to find out the acceleration in both these cases. So now, first of all, this is the pulley. You are given the directly value of that moment of inertia. Suppose if at all that moment of inertia is not given, then you have to apply that for the pulley is considered with a circular disc. So about the natural axis, you have to apply that mr square by 2. But here, you are already given that is the moment of inertia directly, it is a 0.1 kg meter square, that you can apply that value directly in the formula. So that's why 2 kg weight is that, and it is the mg that is acting like this, and the tension will be developed here, and r is equal to 0.1 meter. Now we are supposed to find out what is acceleration, and it is the acceleration of this block or it is the tangential acceleration, that is the of this pulley also. So both are same. So that's why acceleration of this block. And in this case, A is equal to, how to find out, first of all, what is the force that makes this pulley to rotate, and that force is nothing but, it is the torque, that is the tension developed in the string. The tension developed in the string that rotates this pulley. So that's why T is equal to, we are taking the formula, torque is equal to force into perpendicular distance. So that's why T into R is the one formula. And again the second one is a torque is equal to, in this case I alpha is the second formula. So these are the two. Torque is equal to tension into, that is the perpendicular distance is nothing but the radius, and the torque is equal to I alpha. When you are equating these two, TR is equal to I alpha is here. But here you have to find out that T value. Then only you can find out the acceleration in this case. So as I already told you, majority of the problems in this torque and again the parallel axial and perpendicular axial and moment of inertia, they are based on equating the two steps only. One is the torque is equal to force into perpendicular distance, and the second one is the torque is equal to I alpha. Here also it is also one of such models. Now it is the TR is equal to I alpha is there, and here you have to find out the T first. So T value is the, now here it is coming down with some acceleration, means for the simple cases you need not apply that equations. Just it is nothing but the elevator formula. When the person is there and the person is inside that elevator and he is on some weighing machine, if the elevator is coming downwards and with some acceleration A, and the apparent weight of the man is equal to, it is the W dash is equal to M of G minus A we are applying. M of G minus A we are applying because mg is here and this is the mg is here, and the pseudo acceleration of this A will be like this. So both are opposite to each other. That's why we are applying that M of G minus A. And the same formula can also be applied for the tension developed in the string also. The same formula can also be applied for the tension developed in the string also. That's why T is equal to M of G minus A. That's why it is taken as the M of G minus A is there, that you have to find. Now it is the M is equal to, already you are given, it is the 2 kg, and G can be taken as the 9.8 and minus A that you are supposed to find out. You have to find out. So that's why it is the 2 of 9.8 minus A is there, M of G minus A, it is also coming down. Now R is equal to 2 of 9.8 minus A, and R is already given, it is the 0.1, and it is the I is already given, that is also 0.1 is there, and for the alpha you have to apply the formula A by R. Because in this problem you have to find out the linear acceleration, not the angular acceleration. That's why you have to change this alpha in terms of the A, that is the alpha is equal to A by R. Now R is also, that is 0.1, here the 0.1 are cancelled, so it is the 19.6 is there, minus 2A, and it is the 0.1 already cancelled, so is equal to A by, and thereafter R is equal to 0.1. So that is nothing but the 19.6 is there, and it is the 10A plus 2A, it is the 12A is there. 10A plus 2A, it is the 12A. And A is equal to 19.6 by 12. So then you will be getting that correct answer. So that answer is around, it is that 1.63 meters per second square. That is the answer here. So 1.63 meters per second square. So this is also important model. And here the simple concept is, it is the balance in the two torques. Balance in the torques. That is the torque because of this, that is the tension developed in the string and again the perpendicular distance. And the torque is, the general formula is the I alpha. We are balancing these two. So that's why then you are getting this acceleration. And here for this tension, to find out the tension, we have applied the elevator formula. It is the M of G minus A, that is the 2 of 9.8 minus A is taken. That is the first bit is completed, because this problem has a two bits. One is that, and the second one is, if at all a constant, instead of a hanging weight of the string, that is pulled by a constant tangential force of 2 kg weight, then what is the acceleration of the mass? Then what is the acceleration of the mass? So in this case, if at all it is a constant tangential force is applied,